This video is all about vectors. Now let's differentiate scalars and vectors. When we say scalar, it is a quantity with magnitude only. So we have the following examples as 10 apples, 9 bananas, 12 kilometers, 300 degrees Celsius, or force of 25 newtons without any direction. On the other hand, vectors are quantities with magnitude and direction. So we have the examples of this one. Travel 12 kilometers due north. As you can see here, we are given with a distance and its direction as north. Another one is a distance of 3 meters due east. And then we have a speed of 5 kilometers per hour due west and a force of 25 newtons acting in a southeast direction. Now let's represent vectors. Okay, usually vectors are represented with arrows. Okay. Let's read this. Vector B has a magnitude represented by its length arrowhead, represents its head which points in the direction of the vector, and it has a tail or start point. Now we have components of vector. Each vector has two components, a horizontal component and a vertical component. Components are always at 90 degrees to each other. Now, when we solve for horizontal component of vector, AX would be equal to sine of theta. And then for a vertical component of vector AY, it would be equal to a sine of cosine theta. But this is case to case depending on the direction of our analysis. It's either with respect to the x or y axis. In this case, the representation of horizontal component here is in sine of theta. So the analysis of the whole horizontal and vertical component are taken with respect to y-axis. Then we have another representation of vector components. So we have this one as your magnitude of A with the direction of northeast. Okay? So it makes an angle theta with respect to the x-axis. Now, if we're going to determine the horizontal component of force A, so the horizontal component of force A would be in terms of AX. Now, if we're going to further explain this, AX now would be equal to A cosine of theta. So how did it happen? Since AX is an adjacent to this angle theta and hypotenuse of A, so we're going to use cosine is equal to adjacent to the lower hypotenuse and then bringing out the horizontal component, which is AX. So it becomes AX is equal to A cosine of theta. For the vertical component of this illustration of vector, to determine now AY, so this broken line pointing towards the north, this is the vertical component. So let's represent this as AY. So since this line is opposite of this angle theta and just adjacent of this vector or vector with magnitude of A, so we're going to represent this as AY is equal to A sine of theta. Why? Because solving this gets this as an opposite of the angle theta. So we're going to use sine of theta is equal to opposite all over hypotenuse. So bringing out the vertical component AY, this becomes AY is equal to A sine of theta. Okay, just a brief review of trigonometric functions of SOHCAHTOA. Our sine is equal to opposite all over hypotenuse, whereas cosine is equal to adjacent all over hypotenuse, and then tangent is equal to opposite all over adjacent functions. Now let's proceed with vector addition. Vector addition, vectors can be added graphically or analytically. As a rule, vectors are added head to tail. Therefore, the head of one vector is joined to the tail of the other vector it is being added to. This rule is obeyed for graphical addition of vectors, where vectors are drawn on scale on graph paper. Now take note, if we're going to represent the graphical method of vector addition, we're going to incorporate scales here. So let's have this an example. Okay. Here, scale is 1 centimeter is equal to 20 newtons, with parent vectors of 120 newtons at 0 degrees and 100 newtons at 90 degrees. In graphical addition, angle of resultant vector can be measured directly with a protractor. Okay. So it is positive for the x-axis, which has an angle of 0 degrees. Here, the resultant vector is 156 newtons at 39 degrees. So this is the representation. So we are given with, okay, for 100 newtons, it is represented with 5 centimeters because our scale here is this one. 1 centimeter is equal to 20 newtons. Okay. To determine now the resultant, we are given with the problem statement of two forces. The other one is 120 newtons, 0-degree angle, so it points towards the x-axis, positive x-axis. So using now the scale of 1 centimeter is equal to 20 newtons, so since this is 120 newtons through ratio and proportion, if we're going to graph this, 100 of 20 newtons is equal to 6 centimeters. If we're going to determine now the resultant, which is not given on the problem, and it is the unknown we need to solve. So using now our rulers, we can get the resultant of this vector. So the value we got is 7.8 centimeters for 156 newtons. Now, it is better to solve this type of problems analytically or using mathematics. Now we have this analytical method. If we're going to solve now the results, we're going to use the Pythagorean theorem. Okay, so it is 100 newtons squared plus 120 newtons squared, okay, raised to 0.5, or this could be represented as the square roots of 100 squared plus 120 squared. So getting now our resultant, this gives us 156.2 newtons. This is more precise than graphical method. Okay, to determine now the resultant angle theta, we're going to use the tangent function. Okay, so tangent of angle theta is equal to the vertical component all over the horizontal component, ay all over ax respectively. Now, to bring out or to get the angle theta, we need to use the function arctangent to both sides of the equation. So this becomes angle of theta is equal to arctangent of our vertical component ay all over our horizontal component of force ax. Now substituting on the values gives us theta is equal to arctangent of 100 all over 120, or this is in 39.8 degrees. Therefore, the resultant force R is equal to 156.2 newtons at 39.8 degrees with respect to x-axis. Okay, so we have two types of representing and graphing vectors. The first one is this one. We are given with a direction of north and then an angle and then a direction of east, or direction, angle, direction. So how are we going to graph this type of vector? North, 50 degrees east. So we have this one. So start from north going 50 degrees to the east. Okay. So to graph now this vector or this direction, north 50 degrees east, we're going to start from north, okay, and then going 50 degrees to the east. So we have this vector representation. The other one is we are given with an angle, a direction of direction. Again, we are given with an angle followed by a direction of a direction. So how are we going to graph it? So we need to start from the east, okay, going 50 degrees to the north. I repeat, we're going to start from the latter direction, going degrees to the last direction, okay? So start from east going to 50 degrees to north, okay? So we're going to start from east going 50 degrees to the north, okay? So the angle is located here. Now that ends my presentation for introduction of vectors. Okay? Thank you for watching.